Good day, everyone. Welcome to General Chemistry 1 Activity Sheet, Quarter 4, Melc 1, Week 1, Quantum Mechanical Description of Electrons. This module was produced by Region 6, Western Visayas. We have the Bohr's model of the atom and the modern-day model of an atom, which is called the quantum cloud model. The quantum cloud model is the basis of the quantum numbers we are discussing today. So we have four quantum numbers. These are the principal quantum number, the angular momentum quantum number, also known as the azimuthal quantum number, magnetic quantum number, and spin quantum number. So first, the principal quantum number with a symbol of small letter n. This represents the energy level of the electron. When n is equal to 1, the electron is on the first energy level. The farther the electron from the nucleus, the bigger is the atom and the larger is the n value. So here we have the atom with three energy levels. The center, the red here, is the nucleus where you can find the protons and the neutrons. The yellow is the electron moving around the nucleus. When n is equal to 1, the electron is on the first energy level, and it is also called the key shell. When n is equal to 2, the electron is on the second energy level, and it is also called the L shell. When n is equal to 3, the electron is on the third energy level, and it also called the M shell. Then let's go to the angular momentum quantum number, or the azimuthal quantum number with a symbol of small letter L. It tells us the atomic orbital shape. Its principal number is called shell. Within its shell there is a subshell, and there are four known subshells. This is the S, P, D, and the F. E stands for sharp, P principal, D diffuse, and F for fundamentals. The sublevels are designated to the value of L. These values of L ranges from 0 to n minus 1. So if n is equal to 2, then L can be either equal to 0 or 1. So if the value of L is 0, subshell is S, and S has 1 orbital. When L is 1, subshell is P, and P has 3 orbitals. When L is 2, subshell is D, and D has 5 orbitals. When L is 3, subshell is F, and F has 7 orbitals. Subshells are also known as orbitals. Okay, to make it clearer, when L is 0, the orbital is S, or the subshell is S. There is only one orbital here, S orbital. When L is equal to 1, subshell is P, and P has 3 orbital. It has the X, Y, Z plane. When L is equal to 2, subshell is D, or the orbital is D. And D has how many suborbitals here? We have 5. 1, 2, 3, 4, 5. When L is equal to 3, there are, when L is equal to 3, the subshell is F, and there are 7. 1, 2, 3, 4, 5, 6, 7 orbitals. When L is equal to 3, L would be equal to, when N is equal to 3, L would be equal to 0, 1, and N minus 1. 3 minus 1 is 2. So 0, 1, 2 when N is equal to 3. Let's go to the magnetic quantum number, the symbol of M sub L. Tells about orientation of the atomic orbitals along the XYZ plane. The range of values for M sub L is minus L, 0, 2, plus L. So if L is 1, then M sub L is equal to, start with 1 and ends with 1. But on the left side is negative and on the right side is positive. So that would be minus 1, 0, plus 1. Okay. So when L is 0, M sub L is 0. When L is equal to 1, so that means both ends would be 1, minus 1, 0, plus 1. When L is equal to 2, both ends will be 2. But on the left side, it would be minus 2, followed by minus 1, 0, plus 1, plus 2. When L is equal to 3, M sub L would be, both ends would be 3, but on the left side, that would be minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Now the last quantum number. Spin quantum number is M sub S. This quantum number describes the spin or angular momentum of the electron pair in an orbital. Okay, the spin quantum number M sub S. So electron spin could be either positive 1/2 or minus 1/2, or you can draw that as arrow up or arrow down. And remember, each orbital can hold 2 electrons that spin in opposite direction. Numbers and letters are used to name sublevels. So we have 2p sublevel. So the principal quantum number is 2, that is the coefficient before the letter P. And P is the azimuthal quantum number, which corresponds to 1. Here is the summary table of the possible values of 4 quantum numbers. So principal quantum number N has a possible values of 1, 2, 3, 4. Angular momentum quantum numbers L has possible values of 0, 1, 2, 3 until N minus 1. Magnetic quantum number M sub L will just follow the L. So the L would be minus L on the left side and plus L on the right side. Spin quantum number would be either plus 1/2 or minus 1/2. So we'll go now to the activity proper. So, okay, we have write down the possible values of missing quantum numbers. Write your answer on a piece of paper. Okay, so when N is 3, what would be your L? And what would be your M sub L? Now, remember that N has possible values of 1, 2, 3, 4, and the value here is 3. So your L would be starting from 0 until n minus 1. N minus 1, that is 2. 3 minus 1, that would be 2. So what would be the answer here? Would be 0. Next would be 1 followed by 2. Okay? And how about your M sub L? Remember that M sub L would just follow your L minus L on the first and on the left side, and on the uh, right side would be plus L. So that means the number on both ends would be your L. Okay? The ending of your L. So that would be what? You start with minus 2 and then minus 1 followed by 0 followed by 1 and then 2. Okay? So this is your L here. So minus 2 and plus 2. So and between that would be minus 1, 0, plus 1. So 4, 2, and 1 will be yours to answer. Next, activity number 2. Write down the possible values of N, L, and ML, M sub L for an electron in the 2p subshell. Okay, I will give you an example so that you can answer this activity. So, write down possible values for N, L, and M sub L for electron and the 3s subshell. Okay, if it is a 3 subshell, that means the L would be N minus 1. N minus 1. So that means the ending would be what? 2. But always remember, you start with 0, 0, 1, 2. And then your M sub L would be equal to your L on both sides, but differs in charges. So we start with minus 2. Next is minus 1, 0, plus 1, and plus 2. Then you answer the other questions. Activity number 3. Now, so the first one here is already answered as 2s. It says here, given the following set of quantum numbers, identify the subshells in which the electron is located. If one of the value makes the set of numbers invalid, write invalid on the column of subshells. The first one is done for you. Okay, so how do we answer this one? If n is 2, okay, if n is 2, the value of L could be 0. If n is 2, then the value of L will be 0. Because remember, L is 0. L would be 0 and then 1, because the ending of the L would be n minus 1. Okay, the ending of the L would be n minus 1. So 2 minus 1 is 1. So what was given here is that the value here in L is 0. Could L be 0? Yes, it could be 0 because L could be 0 or 1. How about M sub L? Could it be 0? Okay, remember M sub L will just follow L. The ending here is 1. So M sub L could be what? The L is 1, so the first one here would be minus 1 and 0, and then it can be plus 1. Okay, it could be plus 1. So can M sub L be 0? It's possible to be 0. Yes, it is possible to be 0 because of this one here, the 0 here. Okay, so all of this L and M are valid. So now identify the subshell or the orbital. So if L is equal to 0, what is the subshell? Value of L is 0. The subshell is S. So, and what is the energy level of the electron and the s orbital? It would be 2. That is why the answer is 2s. Okay, so you answer 3, 2, 4, 1, 2, 3, 4, 5. Okay, now for more example, if the n is 3, can L be 2? Okay, remember that L will start with 0 and then followed by 1, followed by the last number would be n minus 1. That would be 2. So we still have 2. So can L be 2? Yes, that's valid. Now, can M sub L be 2? Okay, remember that M sub L will just follow L. So this would become minus 2 and then minus 1 followed by 0 followed by 1 followed by 2. Okay, so this is valid because there is a 2 here. Now identify the subshell. Remember that when the value of L is 2, value of L is 2, the subshell is D. That is why we write D. And 3 here comes from the principal quantum number or the energy level 3. That means this electron belongs to the third energy level. For the next example, 1. Can 0 be valid? Remember, L could be what? 0 and then n minus 1. N minus 1 is 0. So we only have 1L. So that is 0. So 0 is valid. How about M sub L? What would be the M sub L? So remember that it will just follow L. So it still be 0. Okay? Now, when L is 0, the subshell is S. And this one here, we get this from here, 1s. That means it belongs to the first energy level. The next example, N is 2, is 1 valid. Remember that we always start with 0. 0, and then 2 minus 1 is 1. that is n minus 1, 0 to n minus 1. Okay, it is 0 to n minus 1. So is 1 valid? Yes, it is valid. How about f sub L? Remember that it again follows the L. So it starts with minus 1, followed by 0, followed by 1. So is 0 valid? Yes, it is valid. And remember that if it is 1, L is 1, the subshell is P here. And this 2 came from this N, 2P. Let's go to the last. Is 3 valid? Okay, we'll see if is 3 valid. Well, remember we start with 0, followed by 1, and 4 minus 1 is 3. 2 and 3. Okay. Now, is 4 valid? Looking at the L, you can see that 4 is not valid because this M sub L will start with what? Minus 3. Okay? Minus 3. And minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So that is why number 4 is invalid. The answer here is invalid. Okay? So you answer the reflection, and that's all. So I hope that you learned something from our lesson today. And if you learned something, please like and subscribe to my YouTube channel. Thank you very much.